Hello, everybody. Welcome to the Henstitute. This one's kind of a neat one. I actually found this in an old physics book of mine where they talk about okay, if we had all these guys pulling the block up the incline, how many men would you need, and all that lovely stuff. And we treat that kind of if we put it on a little sled and stuff like that. So we've got the mass of the block is this 3 times 10 to the 3 kilograms, so 3,000 kilograms. And the angle is given and all the lovely stuff. But we have two different frictions here. We have a coefficient of static friction and a coefficient of kinetic. So the first question wants to know how many men are needed to pull the block. So the idea is each man can pull with 577 newtons. So really, if we can figure out the total force needed, we should be able to figure this out. So if I think about it, what I have is there's going to be a tension in this rope. And that tension is basically how much these men are pulling. Because if you think about it, all that's doing is that's just transferring it up here. So that's what I'm after. I'm after Ft. Other forces that would be acting. So I know anything that's on an incline like that, I have gravity acting on it, but we always break that up into a parallel and a perpendicular force. So there would be a component of its weight that would be acting in this direction. I'll call it F parallel. And then we know we've got our F perpendicular here as well. The only reason that's going to be important is because we also have a normal force acting. I apologize, my drawing is not the best on this board, but those two are going to equal each other, so that's going to be important. The last thing we have is we have friction. Since I'm going to be pulling this block up, friction is going to be acting down the incline. I'm just going to write it as friction for right now because the first part says, assuming negligible friction at the point of the, so don't have any there, how many men are needed to put the block on the verge of moving? So the idea of part A is we want our force here to overcome static friction. So I'm going to start with part A here. So to solve part A, what I'm going to do is I'm going to say the tension force should equal those two forces. So they're going to equal the parallel force plus the friction, but it's going to be static friction because we're trying to start it moving. So I'm after that tension force, so I just have to find the other things. Well, we have a way of finding that. The parallel force is just the mass times gravity times the sine of the angle of the incline. And the static friction force would normally be, so if I think of static friction, this is actually going to be maximum static friction, if I get really picky, is going to be the fun equation, so it's going to be static friction times the normal force, but the normal force is just equal to the perpendicular force, so I can put that in, and I know how to find the perpendicular force. So I'm going to combine those together, so this is going to be mu times s, and then mg cosine theta. And you put those together, that'll be the tension, so that'll be how much they have to pull, and we're going to use static, so this is the force just barely to start it. So think of when you were actually pulling the block, and with your force sensor, when you first got it moving, you were overcoming static friction, so that's what we were trying to do. We didn't have to worry about the parallel force or anything, so that made it a little bit easier. So that's the first part, pretty straightforward. And then once you find that, to actually find how many men, we're just going to divide it by 577. So the number of men would equal this tension force in the rope divided by 577. Now, my idea is I would probably round it up to the nearest whole man, and I would round it up. So if it came out to be like 13.2, I would round it to 14 because you wouldn't be able to do it with 13 men. They wouldn't be enough, and 14 men should be enough. So that was kind of my thought of this problem. Next up, part B. So once it is moving, what is the acceleration of the block? So now we're going to go to F equals ma. So the acceleration would be the net force divided by the mass. So we know the mass, the 3 times 10 to the 3 kilograms. Here's the net force. So go back to my picture, my free body diagram. The net force would be the difference between these. So if I'm looking at acceleration, the net force here is going to be the tension force minus my parallel force minus friction, but this time it's not static friction because now it's moving, so it's going to be kinetic friction. And then divide by my mass. But I can calculate all of that. This is going to be put in there. We should be able to calculate that. So my tension force minus all those lovely things. But I'm going to show you one thing that's kind of neat with a couple of little things. So this is how I found the tension force. So I should be able to substitute that in there. So it's going to be mg sine theta plus mu s mg cosine theta. Then how do I find the parallel force? Well, that is mg sine theta. Wait a second. I have an mg sine theta and a negative mg. So those are going to cancel each other. So that's going to be irrelevant to my problem because the way I found that tension force, the force needed to start it moving, was actually equal to it. Now here's the major part. I also have the minus, but it's kinetic friction. So this is going to be minus mu k mg cosine theta. I apologize, I'm kind of running out of room. And then the whole thing over m. One of the other things you notice is everything has an m. Bye bye m's. The mass is actually going to be irrelevant for my acceleration. So if I kind of look at this, I really end up with mu s times g cosine theta minus mu k times g cosine theta. So if I think about it, I can actually pull out that g cosine theta, and it's the difference in the coefficients times g cosine theta, which I just think is fascinating. That's just kind of cool that's kind of, it's the difference in the coefficients. So the closer they are, the smaller your acceleration. If they were actually the same, you would have no acceleration. But just kind of a neat question. Hope that helps.